when we're talking about a GCF, right, we're talking about this, the greatest common factor. Now, when you think about the greatest common factor of each set, it's either done by expanding all the numbers as a product of its prime factors, right? So if I was looking at 12, I would do that weird thing that I showed you earlier in the class, right? So with 12, I would sit here and I'd go, okay, here's 12, right? And then I go and say, all right, let's go and break that down. If I divide it by 2, I get 6, and then 6, and then 6 could also be divided by 2 again, right? That gives 3, and then 3 can only be divided by 3, and 3 divided by 3 gives us 1. So guess what? The factors of 12 are this, right? Now that I've got that, I could do the same for 8, couldn't I? Right? So if you didn't know what the common factor of 8 is, what the greatest common factor of 8 and 12 is, you just break it down. So you look at 8, it's an even number, divided by 2 gives 4. 4 divided by 2 again gives 2, and then 2 divided by 2 is 1. So in order to find the GCF, what you have to do is you have to match the number of 2's and 3's together. So in this case, I have a 2 here and a 2 here, right? I've got a 2 here and a 2 here. So that means the GCF of 12 and 18 is 2 times 2, which is 4, right? So that means the GCF is equal to 2 times 2, which equals 4. Now, you guys are pretty good at this in the sense that you could easily, back to the lesson. So one of the things that you guys can do with 12 and 8 is if you can quickly, now, one of the things that you could do is you could do this by inspection. You could look at it and say, okay, the biggest number that divides 12 and 8 is 4. And you check it one more time, boom, you're done. And I know that a lot of you have already practiced this, so you already know how to do this. So now, I want you to do the GCF of 6, 8, and 24. Yep. How'd you get it? Right, so it's the only number that 6, 8, and 24 all divide into. And it's the biggest number that is shared between them. So in that case, we're going to say the GCF is, CF is 2. That's it. And we're done. And we did that literally by inspection. So now let's move on to our next problem. So this one is asking us to find the GCF of each pair of terms, right? So if I have 5 cubed and 5 to the 6, the rule is you look for the lowest power between them. And that is your GCF, right? Because if you think about it, doesn't 5 cubed divide 5 cubed, right? And doesn't 5 to the 6, isn't that also divisible by 5 cubed, right? Right? And you would be left with 5 to the 3, right? So the rule is we always take the smallest power. Yep.
Can you scroll to the left a little bit?
I will. I will.
Because
We'll work on that. Okay.
it doesn't seem like it's working like that, sir.
So in this case, this is going to be the smallest power. And the smallest power in this case is 5 to the 3 is our GCD. GCF. Okay?
Say GCD.
That's greatest common denominator. I apologize. Sometimes I mix that up. Oh, count it. Ren, count it. For the next one, let's take a look at this one. This one's going to be a little confusing. So I have x to the 4 and x to the 7, right? If I'm going to do this using what we did before, we're going to use the lowest power between them to be the thing that divides both. So what in this case is the GCF? It's not 4. The GCF is, ready? X to the 4.
What? You just...
Yeah, it is x to the 4. Think about it. Let's go back and take a look. So before when we did this problem, right? When we did the previous problem, the base of the exponent was 5, right? Now, because the base was 5, we use the lowest power for both of them, which is 3, right? Now, in this case, when I have a variable raised to a power, it's like removing the number, but you kind of could use any number there, right? So in this case, we're saying, okay, if it's a letter, we're using the lowest power of the letter to be the GCF between both of them, right? That's it. Does that make sense?
Yeah, what about the next one, sir?
So the next concept that we have to do is we have to talk about pulling both together. Now we're going to go and take a look at numbers, the coefficients sitting in front of our number, of our variable, and the exponent. So let's go and take a look at this one. So now, when we look at this next one here, we have 3y squared and 9, okay? All right, so we got 3y squared. So we got 3y squared and 9, right? What is the GCF? What is the GCF between 3y squared and 9? Start with the numbers. Start with the numbers. 3, right? So in this case, the GCF is 3. Some of you guys would say, hey, you know what? This should be y something. It should be 3y or something like that. You'd think it would, but guess what? It isn't. Because if you think about it, if I don't have a letter sitting right beside this, this 9, it really means y to the 0. What's y to the 0? What's anything to the exponent 0? 1, right? So the lowest power is 0. Y to the 0, right? So here's the rule. Here's the rule. If both terms have a letter, you use the lowest power of the letter, right? But if one of them is missing, the only thing that you care about is the coefficient that is sitting in front of those two, in the front. That's it. That's it. It's just 3. It's just 3 in this case. Because 3 and 3 divides 3 and 3 divides 9. But because both of them don't have a y, we say that there's no GCF for the y. Does that make sense? Right? Okay, so now let's go and take a look at our next problem. All right. So our next problem is this. It's crazy, right? What's the biggest number that divides the 21 and the 28? 7. All right. So the GCF, so we start by looking at the coefficient, and we find out that the GCF is 7, right, for the coefficient. So now we got to look at the letters, right? We have to check to see if our letters are in both of them. In this case, I have c squared and I have c cubed, right? What was the rule when we had our letters in there? Did we use the highest power or the lowest power?
The lowest one.
The lowest power. So in this case, we're going to say the lowest power between these two terms is c. The lowest power for c is c2. So we're going to say the GCF is 7c squared. Now, we go and look at the next one, right? We go and look at the next one. Both of them have a d in it. So we need to use the lowest power to get the GCD. So the GCD is going to be 4. So the final answer is 7c squared d to the 4. Now what that allows us to do is it allows us to do things like divide stuff out really easily, right? Now,
Sir?
the third page of your practice work is the actual questions that we're doing for the day. So go and take a look at question number 1 and try it out. And so now, let's move on to our next problem here. So in the last those two examples, right, you notice that the GCFs were the coefficients and part of the variable, right? That's what was going on. So that was at the very end of the sheet, right? So now here's what we're going to do. We're going to go take a look at the next problem here. Oh yeah, I split it, didn't I? Now, for each one of these questions that we did, which you can find on your practice sheet, you'll notice that for this one, we have 2x and 3x.
the only thing that's common between them is x. You'll notice that we really just have x, and we don't consider the fact that we can only divide the 2 and the 3 as the common factor by 1. So because it's a 1, we don't consider it as part of the answer for our GCF. So we just write x as our final thing because x is the lowest power that both of them have. So now when we go to question number 2, B, we look at this problem here, and you'll notice that basically we have the following happening. We have 6AB and minus 8AC. Now, the only time we end up with a negative as part of our answer is when there are both negative. It was when basically you have a negative number on the front of one of the terms and a negative number on the other. So it's the only time we consider that. Now, this problem here has 6 and negative 8. Now, 6 and 8, the only thing that divides both of them is a 2. So we end up having a GCF of 2A. Now, the only issue is where do we get the variables? So in order to understand where the variables come from, we have to look and see, oh, notice there's an A here and an A here. And based on that, the lowest power is A. So guess what? We write 2A as our final answer. So for our next problem, we have x squared and x cubed. The rule is we're going to take the lowest power. And that lowest power allows us to allow both of these terms to be divisible by, say, x squared. So if I divided this by x squared, I'd get 1. If I divided by this x squared, it would be x is 1. All right, now, let's continue with the rest of this problem set. Now, for question D, you have k to the 4 and k to the 7. The lowest power is 4. So the GCF is K4. Great job, guys. Now, for this one here, the only thing that we can have is the letter M. And the reason why is because the GCF of 3 and 5 is 1. But for M squared, we look at the M's and we look for the lowest power. So the lowest power is M. And that's it. And that's how we got M for this problem. Now, let's move on to the last problem for the day. So now we have negative 12y squared and negative 15y to the 4. The rule is if I have a negative on both coefficients, which are these things here on our terms, we pull out the minus 3 in order to make our life easy. So we pull out the minus sign, and we use that as part of our answer for the GCF. So in this case, 12 and 15 can both be divided by 3. So the answer is going to be negative 12, and then the lowest power is y squared. Perfect. Just remember that only issue is that when we have a double negative, we basically bring that down as part of the GCF. Now, let's move on to the next topic. So when I look at these, right, these are monomials as GCFs, right? I know, it's because I imported it from a Word document rather than a PDF document, okay? So now, the reason why that little upside down squiggle is there, just ignore the squiggle. Ignore the upside down thing. It's just the computer going, what the hell is that? All right, so the reason why we're saying this monomial, this thing has a common term. So if I look at this thing, 8x and 2. What is the GCF of 8x and 2? 2, because 2 divides 8 and 2 divides? Right. So now, in this case, we can write this as equal to 2. And then here's what I want. Imagine that I pull the 2 out, that monomial of 2, right? Now, here's my question. Think of it this way. Each one of those terms has been, imagine, there's a division by 2, right? So what is 8x divided by 2 going to give me? So I got 4x. And then what is 2 divided by 2? Is it 1? Is it plus 1 or minus 1? Plus 1. That is it. That is literally it. We use the GCD from these two terms to get the number in front. And then what we do is we divide all those numbers by what's in front and put the result inside that bracket. I call it garbage collection, right? Now, when you take a look at this one here, look at the next one. Let's identify, is there a number that can divide both of those, right? What? And now look here, is there a GCF between 10x squared and 7x? So there's a 1. Okay, we'll put the 1. All right, we'll put the 1. What about the variables? It's x. The lowest power is x, right? So now let's do the garbage collection. So if I take 1 divided by 10, what do I get? 1 divided by 10 gives 10, right? Now, x squared divided by x, how many x's are left? Just x, right? Ready? 7x, so I got x divided by x is? What's 3 divided by 3? So what would x divided by x be? Yeah, minus 7 times 1, right? So when I divide 7x by 1x, the negative 7 gives me negative 7, but then the x divided by x, nothing, right? Does that make sense? Does that make sense? Just want to know. Let's go and look at the next problem. I'm just going to move this over a little bit, and I'll leave the previous one there. Now, look at the coefficients of this one. We have 30a cubed and 20. Whatever, right? What is the biggest number that divides 20 and 30? 10? Are you right? Are we right? 20 and 30, are we right? It's 10? All right, cool. So we're going to go and pull off 10. So now, once we've pulled off 10, here's my question, right? We have to look at each of the variables here. We have to say, hey, is there an A here and is there an A here? If there is, we got to use the lowest power. So a squared. All right. And last one? B. All right. So now, let's go and do the garbage collection. What's left in the bracket? When I divide 30 by 10, what do I get? 3. So I get a 3, right? A cubed divided by a squared. How many a's do I have left? Just one a. So we're just going to write 30a. Oh, 3a. 3a.
30, no, sir.
So we have b divided by b in the first one is gone. Now what about the 20 in the next one? Is it plus 20 or minus 20? So it's going to be plus 2 or minus 2? Plus 2 because we took 20 and divided by 10, correct? So now this is going to be plus 2. Now let's take a look at those a's. I got a squared divided by a squared. Do we have any a squareds in the final one? No. What about the b squared divided by b? So there's only one b left. So we write to be or not to be. That is the question, right? Whether 'tis noble to suffer the slings and arrows of misfortune. Now, I'm not going to lie, your misfortune is this last one, right?
Why?
What is the number that divides 3 and 8? If nothing, you're going to say?
1.
Right. So, since we've got that, we're going to go and say we're going to start with 1. So it's equal to 1. How many x squared? Are there any x squareds between both of them? No. Are there any y squareds between both of them?
No.
Are there any w's?
No.
Any z's?
No.
Right. So guess what we have to write? All right. Now, the moment I see that, the moment I see a 1 sitting in front, I'm like, oh, brain broken. I go and rewrite it. Just copy pasta. Yes. Ah! Ren.
Twice.
Count it twice, Ren. Count it twice, Ren. And Z. All right.
Okay, so let's pause. So the next thing that we're going to do is we're going to try the binomial as a GCF. Okay, so that is the next thing we're going to take a look at. So now, so when we're looking to identify a binomial as a GCF, right? We're looking, a binomial is something that has two terms in it, like an addition or something, right? The key is, remember what I said to you guys, when you're dealing with this stuff, we're looking for a pattern, right? Do you see a pattern in there that looks the same for the first question? Yeah, so basically, if I highlight it, basically the z plus 1 and this z plus 1 is the same, right? So just like what we did before, we pull the stuff that is the same to the front. So when we do this, we're going to write this as z plus 1. Now, here's my question. What is the garbage collection for this one going to be? So imagine I divided everything by z plus 1. What goes in the garbage collector bracket? Huh? What goes in the bracket? So this stuff is times z2x, and then this stuff is times 5y. So what do I have in the bracket? Any idea? 2x plus what? Plus 5y. Right? So when you see a matching bracket, the key is to pull the bracket out front and then use the garbage collector to basically put the rest of the stuff in there. Right? So now let's go to do the same for this next problem. Same idea. Going to zoom out so we can see it all together. Right? We've got 6 x minus 3 minus 5y times x minus 3. So when we're doing this problem here, 6 bracket x minus 3, you'll notice that we have two brackets which are exactly the same. Those brackets are what we're going to pull to the front as our, what would you call it again? Our GCF, right? Because this is because this thing here is a multiplicative complex, and this is also multiplicative, right? So this means 6 times everything inside this and 6 times everything inside that, right? So now what we're going to do is we're going to basically take a moment and we're going to pull out that x minus 3 because that's the thing that's common. Now that I've done that, right, I have to have the garbage collection. I have to say, okay, if I pulled off x minus 3 from this first block, what am I left with? I'm left with 6. I'm left with 6, right? And then for the other block, I'm left with minus 5y, right? Now, there is a third problem that we have on this sheet that we got to go over, right? Okay, so let's go and do that. But when we do this, we're going to make sure that we have the original problem for number 2 up on there as well. Now, this one is important. The reason why is it important is because when you take a look at this y minus 1 and this 1 minus y, they're almost identical, aren't they? Right? The only issue is that y is positive in the first one, but it's negative in the second one, right? And negative 1 is negative in the first one and then positive in the second, right? So it's a difference of minus 1. So what we're going to do in order to make our lives easy is we're going to rewrite this equation. Start by writing equals 3x y minus 1. But I want you to imagine if I had divided everything or pulled out a minus 1 and used minus 1 as my GCF for that, right? So this plus 1, so this plus thing becomes minus 1 bracket y minus 1. Yeah? So now we've got what we're looking for. We've got stuff that matches, right? Get it? So we got stuff that matches. So now we're going to pull out the y minus 1 on the next line. So we're going to go
y minus 1, and then we're going to have our little garbage collection. All right? So we end up with, for the first bracket, 3x is left over, and the second bracket, it's minus 1, and we're done. Now, your job is to go and take a look at question number 5 on your worksheet, and you're going to do the factoring by grouping. You're going to see questions that look like all of these 3 problems here, right? These 3 problems, by basically factoring by grouping, is what we're going to be doing in order to do this thing called factoring later on, right? So I need you to understand this, so make sure you go work on question number 5 right now. So now we'll go to factoring by grouping, real factoring by grouping, okay? You'll see it on your sheet. It looks like this. So when we're talking about factoring by grouping, we're talking about trying to find blocks of 2 things and then common factoring those groups of 2 things in order to make something happen, right? Now, let me show you how we're going to do this. All right, so the rule is when you look at the first problem here, right, you have ax and y, ay, and you have, what is this? Plus 2x and 2. Hold up. There's an x and a y in both, right?
Yes.
So what happens if we take our first thing and we group it to be ax plus ay? And then we go plus, well, 2x plus 2y. Now, once we've done that, we can common factor each of those 2 groups. Now, you'll notice I put a plus here, right? And there's no plus in front of the 2x that is to the right of it, right? Now, if it was a minus, if there was a minus right here, I would want you to put the minus inside the bracket as well and put a plus in between them. So there's always going to be a plus between the brackets, because what we're essentially doing is splitting the equation into 2 halves, 2 additive halves, right? Now you'll understand why later, because here's what we're going to do. We're going to take a look at this, and we're going to say the first bracket, what is common to the first bracket? Tell me, nice and loud. A. It's A. So we're going to pull off A, and then we got to say what's left over. X plus y. And then for the second bracket, what's common to it? 2. So we pull off the 2. That's easy. So now we've literally factored it. We have groups of stuff in brackets. This is what factoring by grouping is. You factor in such a way where you recognize that there might be a possibility of brackets that are the same, and we pull them out to the front. So let's do what we did before. So we're going to go x plus y, and then we collect the garbage. A plus 2, and we're done. All right, so now let's go and do a slightly more difficult problem. So we're going to zoom out like we did before, and we're going to try to make sure that we have both problems showing up on the screen here. So now the second problem has 9x squared, right, plus 15x plus 3x plus 5. Now, what you're going to do is you're going to split the problem into 2 halves, right? Here we go. So we're going to put a bracket here, and we're going to put a plus and another bracket over here. Now we have, in our first bracket, we have 9x squared plus 15x. And the second bracket, we have 3x plus 5. Now, taking a look at the first bracket, what do we have there? Taking a look at the first bracket, what can I pull out? Quick. I can pull out an x, but what is common to both 9 and 15?
They're numbers.
They're numbers, right? But what is the common factor for 9 and 15? 3. So we pull that out, so we get 3x, right? And what's left over? 3x plus 5. Excellent. So now, here's the question. You notice I got a 3x plus 5 over here, right? What is understood to be in between this plus and this bracket? Yeah? A 1. Excellent. A 1 is what we expect to be there. So we just put it in. So now we do what we did before because we bad like that. So we pull out the 3x plus 5 since it's common to both multiplicative complexes. And then we end up with 3x plus 1 into the second bracket. Okay? And so now, what I'd like you to do is I'd like you to try the next one here. This one is deliberately annoying. Yes, it looks like you can do it, but you can't. Why? It's impossible, right? So sometimes you'll see some weirdness in your work where you're like, hey, this might work. Let's put it into bracket C. You check it out and you're like, wait a second, I can't factor out anything in the second bracket, right? So this part can't really factor anything out, can it? Right? So we got to leave it, okay? All right, so your work for today is this, 6 to 9 and 11, right? If you are understanding everything else, I expect you to work on question number 12 and 13AB.
I want to do that.
Okay? Good luck, guys. Now, for these ones, we're taking a look at an expression, and we're finding the GCF of the expression and then dividing the numbers out. So in this case, for 15 plus 25, 15W plus 25Z, you have to think of it as this way. Okay, so the only thing that's shared between them that could make the GCF is 5 because it doesn't share any variables, right? Then what we have to do is we have to imagine that we're dividing this whole thing up here by 5. So we put the 5 down and then we're left with a bracket. And that bracket is going to hold the results of us dividing 15W by 5, which gives us 3W. Because there is no W, the W stays. Now, when we have 25Z, we divide 25 by 5 to get 5, and then we just bring down the Z. Now, let's go take a look at the next problem here. For 3A minus 11B, right? This is what Jada would call a copy pasta. The fact that the only number that can divide both the 3 and the 11 is 1. And there is no shared value between these two. So that means we're literally going to just get 1 times the quantity of this. Now, 1 times anything is just the original back. So you don't really need to go and factor it. So the moment that you find out the only GCF is 1, you just give me back the final answer. You understand? So you just give me back this. You're done. Now, let's go take a look at this next problem. And basically what it is we have 17CA plus 8CD. Now, for 17 and 18, the GCF is 1, so we don't even have to worry about the coefficient number 1. We don't need to worry about that. But we do notice that both of these terms have a C in it. Now, the C is what the common factor is going to be. So we're going to put C and then bracket, and then we divide our 17CA by C. So C divided by C is just 1, so it just goes away. And then we're left with A as our final term left in it. And we do the same for this part here. So C goes away when we divide that by C, and we end up with negative 8D. And we're done. Now, these are the final sets of problems that we did for this problem set, right? Now, they're not that difficult. They're just a little annoying, right? So this one here is a little small. So what I'll do is I'll take it and I will make it just a little bit bigger. And I'll put an answer right there. Okay? And we will be done in a moment. And we're done. So let me just put this up on the screen so you can see the answers together. All right. And here we go. There you go. All right. That's it. That's all the solutions for today's work. So take a moment, use this, do some practice, and we'll get back to this tomorrow. All right. For this one, this set of questions here, questions number 4, odd, right? A, B, D, G, and H. What we're going to do is we're literally looking for the numbers that match. In this case, we have 14 and 16. So that's the coefficients, right? So we look for the biggest number that divides 14 and 16. In this case, it is 2, right? Then what we're going to do next is we're going to make sure that we look at all the x's, and we're using the lowest power of x, and we're going to put it as one of our terms for our GCF. Okay? And then we're going to do the same for our y's. We look at both y's and we use the lowest number, the lowest exponent. In this case, it's just the y. So we'll just copy that across to here. So now what we have to do once we've done that is we are just literally going to divide out our 2xy into our original equation and then put the result in the bracket beside. So 14 divided by 2 is, you guessed it, 7. And then x squared divided by x leaves only one x, and y divided by y gets rid of that because it's a 1. And then we do the same for our 16xy squared. So you've got 16 divided by 2 gives 8, and then x divided by x cancels it. And then we have y squared divided by y leaves us a y, and we're done. There's not much left to it other than understanding that sometimes our equations require not small numbers that necessarily go into each number, but the biggest number that goes into each number for our terms. In this case, for question G, you'll notice that I have 27, 8, and 36. Now, the only thing that divides all 3 is 9. At first, we thought it was 3. And 3 definitely divides into it. But when you simplify, you realize there's more that comes out. So we got to look to see if maybe 6 or 9 works. And when we checked 9, 9 was the biggest number that divided it, divided all 3 terms. And that's how we got our 9, our 3, our 2, and our 4. And we're done. All right. Move on to the next set of lessons. So now let's work on the factoring by grouping section of work here. So you'll notice that for this problem here, 3x times bracket x plus 8 plus 5 bracket x plus 8, you'll notice that there is, I call it a multiplicative complex. So if you look here, this is all multiplication and this is all multiplication. And the reason why that is because a number or a term is squished beside another bracket. Now I could have had a bracket beside a bracket. The same thing would be considered a multiplicative complex. So now, if you think about it, right, this and this are the same. So what we're going to do is we're going to common factor those brackets out to the front of our stuff, and then we use our garbage collection here to say what's left over after we've pulled off x plus 8. In this case, we end up with 3x plus 5, and we do that for every one of these problems. Okay, now the only problem that will probably give us a little bit of trouble will be this one here, question D. Now, you'll notice that we have a minus sign here, right? That minus sign that we have right here, minus t, still stays as minus t when we put it into our garbage collected bracket, okay? Now, there are more difficult problems on here that follow the same pattern as pulling various numbers or brackets to the front. And that's it. Now, this one here, part C, is the most difficult part because at one point you see that you have an x minus 5 and an x plus 5. And the only way this would work is if I had something like this. If I had negative x plus 5 or x minus 5 inside this bracket, would this have worked? Because if I had negative x minus 5, I could have pulled out a negative 1 to make it be x plus x minus 5, so it would match the first bracket. Okay? So right now, there is no way to make those two things the same. So what we're going to do is you're just going to have to accept the fact that you can't factor this because there is no bracket that works nicely with this. Okay? And that's it for this section that we practiced in class. Now, what I would like you to do is I would like you to work on question 6 through 9 and then question 11 at least. Choose your own questions from those and we'll take a look at them.